So let's get started. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. And I've been to Krakow a few times for different conferences, but it's the first time here in GeeCON, so I'm happy to be here. Today I'll talk to you about what I call the common large language model pitfalls. So what are some of the problems with large language models? And more importantly, what you can do about them. Everything I talk about today, they are already on speaker deck. So if you want to get the slides, this is the link. And then if you want to also look at the demos that I'm going to show, they are in this repo, personal repo that I have. So everything I show you today, it's already available to you. And before I forget, this is the place to ask questions because I can't see you at all. So if you have any questions, put it here. And hopefully I will remember to come back and answer questions either throughout the talk or maybe afterwards. All right. So what we're going to do is that first I want to do a really quick introduction to large language models. I know we all know about them and we all are using them, but just to kind of look at them, to look at the latest and greatest on large language models and know where we are. And then we'll go through the problems, the pitfalls section. So what are the common problems with large language models? Then we'll look at solutions. That's the important bit. And then we'll finish with some summary. All right, intro. Well, first of all, let's not forget that large language models are kind of a small piece in this big AI landscape, right? So at the top level, we have the artificial intelligence as the field. Then we have machine learning, which is a type of artificial intelligence. Then we have deep learning, which is neural networks, a type of machine learning. Then finally, under that, we have generative AI, the part of AI that actually generates things. So it started with text and large language models, but now we have things like image generation, video generation, audio generation. And actually, the large language models and this image, video, audio generation, they used to be separate models, so you typically use different models for them. But now I kind of moved this large language model kind of over the top of the image generation as well, because some models, like Gemini 2.0, for example, it started also generating images. So you have the same model for text generation and image generation as well. So in the future, maybe we'll have models where it's just one kind of model and it just generates whatever you want, right? So that's where we are, and that's the landscape that we're in when it comes to large language models. Now, in terms of the landscape of large language models, then we have different models like GPT and Gemini from Google, Cloud, and DeepSeek, and things like that. I used to try to keep track of all these models, the versions. I kind of gave up on that because every month there's something new and it's really hard to keep track. But if you go to this link, there's a nice table that shows you all the different models and their capabilities. So it's good to kind of check it out once in a while and make sure we're at least aware of what's the latest. Now, when it comes to Google, there's Gemini. That's the main model that we have, and then there's different versions of that, the latest of which is Gemini 2.5. But keep in mind that Gemini is not just a model, but it's also a brand. So we have the Gemini model. That's like the model that powers everything. And typically, you would start using that from what's called Google AI Studio that I'll show you later. It's a browser tool where you can try different models. But at some point, you probably want to deploy that to, you want to probably write an application and deploy to cloud. So at that point, you would switch to Google Cloud, and there's a section of Google Cloud called Vertex AI, which is the AI platform of Google Cloud that not only has models, Gemini models, but also other open source models, and also all the tools that you need to build an application. So that's kind of the Google AI landscape. But then you also have the Gemini apps. So you have the Gemini app, the chat application. You have the Gemini Cloud Assist and Code Assist for code generation or helping you with the cloud. So when you hear Gemini, it's actually more than just a model, but all the things that are powered by the model as well. So I just want to point that out. And then there are different ways of using it from Google AI Studio or Vertex AI Studio. I'm going to show you both as we go along today. And the unique thing about Gemini is that it's multimodal. So you can send text, images in, and then you can get like text and images out. It has a multimodal live API, which basically allows you to kind of talk to the model, and then the model can see what you have, like, so you can send video feeds to it, and then it can actually see and respond to you in real time. So it really enables you to write like real-time kind of applications. And it has a very long context length, and that's one of the unique things about Gemini. And just to compare, right now it has Gemini, this was Gemini 2.0, it has 2 million context window, which allows you to send like 2 hours of video, or 22 hours of audio, so on and so forth. So this allows you to really send a lot of data or code or whatever, and let the model see that all at once and give you insights on that. So that's also something unique about Gemini. And if you want to run your own models, there's the open source version of Gemini called Gemma. So you can think of this as a slimmed down version of Gemini, but you can run it anywhere you want. And it has different flavors like Gemma for coding, Gemma for images, stuff like that. So I'm not getting into that, but just know that there's a open model that you can also use if you don't want to use the cloud version. All right, so that was a really quick introduction. I just want to make sure that we're all on the same page. And just to show you just a quick demo, for example, like here I am in Google Cloud Vertex AI. Let's say I have this video. And this is a video from Rio. It's showing some scenes from Rio. And then if you just want to analyze this video, you can just write a simple prompt, just say, you know, can you chapterize this video by content and show me the main chapters? I'm using Gemini 2.5 Flash, which is the latest model. And then we just run that, and then it will take a little bit of time because we are sending a video, or at least pointing to it, and it will analyze it, and it will give us, hopefully, it will give us the chapters from the video, right? And this, I mean, we'll look at the code, but it's literally a single API call. Like, you just point to your video, and then and have a prompt, and then you get this chapters of the video pretty easily. And I think if we look at the code, this is Python, but there's also, well, there's no Java here, but you can also do this in Java. But you see, like, you basically just point to your video, and then some configuration, and then just generate, and then you get the result. So using large language models is very easy, and what you get back is a lot of information analyzed and given to you in no time, really. But unfortunately, this is part of the story. I mean, it's very easy to get started, but there are a lot of problems with LLMs. So that's what I would like to outline now, and then we'll look into what we can do about them. So what are some pitfalls of LLMs? Well, number one, even though it's very easy to use an LLM with a single API call, you typically need some kind of pre-processing or post-processing after the call, right? And especially if you need to do something like RAG, Retrieval-Augmented Generation, that I'll show you later, you have to do that. You have to do some pre-processing and post-processing, so that it's not as simple as just making an API call. There are things you need to do, but there are frameworks that can help with that. So that's number one. The second and more important thing is that LLMs hallucinate. This used to be a bigger problem. It's getting better with the newer models, but they still make up facts. And this happens for different reasons. They hallucinate because sometimes they don't have they don't know what you're talking about. They're not trained with the data, or maybe their data is outdated, but they will give you an answer anyway, right? And you don't know which answer is correct or not. So you need to be aware of this. And then sometimes they hallucinate because you ask the large language model to calculate something, and large language models are not great at calculations, so it will kind of make up something and tell you this is the answer. It's usually not true. So if you're doing some kind of calculations, usually they're probably wrong unless you do something which is called code execution that I'll talk about later. So hallucinations is a big problem, lesser problem, but it's still a problem. And large language models, they rely on outdated public data, meaning they are trained with data from a few months ago. Like Gemini, the latest model, was trained maybe like 3-4 months ago, and it knows data from that time frame. But if you ask something about today, it wouldn't know by default. So its data is already outdated, and it also only relies on public data. So if you have any kind of private data, it wouldn't know about that, right? So you need to know this. The outputs of LLM, they can be chaotic. again, this is one of those problems where it used to be a big problem, where when LLMs first came out, the output was pretty much any kind of text you can imagine. Like it was free text, it was Markdown, it was JSON, and worse, it used to be like malformed JSON. So LLMs were almost trying to trick you, where they would give you JSON, but there would be some errors in the JSON so that you can't parse it automatically. So you always had to do something on the output and kind of assume that there will be a problem. This is getting better, but it still can be a problem, but there are things you can do about this. LLM calls can get expensive, especially if you do calls with large files like videos and stuff like that over and over again. They can get expensive, or if you don't batch your calls. But there are things you can do to keep the expenses down, and we'll talk about that as well. LLM calls can be slow. You've seen in the video example I showed you, it took 10 seconds or so to kind of analyze the video. If you send a bigger video or if you use a more advanced model, they tend to be slower. So you need to be aware. Like sometimes it's okay if it's slow, but maybe in some use cases you want it to be fast. So you need to choose the right model or do right things so that it's not as slow. And we'll talk about what we can do about that. The output quality of LLMs is very hard to measure, and I think this is one of the biggest problems of large language models today. They give you something back, but how do you know what you are getting back is good, right? And what do you mean by good as well? Like you need to kind of quantify that, and then once you quantify it, how do you measure it? What do you measure? So there's a lot of things we need to kind of think about and do here. Make sure that LLM is getting us good quality output. Especially, LLMs are not non-deterministic, so they give us different results all the time. So we need to make sure that what we are getting back is actually decent enough. And then the outputs can contain personal information. So if you send personal information to the LLM, it can respond with personal information. It can have harmful content, bias, things like that. So you can't just rely on LLM to do the right thing. You need to kind of guard against them. So we'll see what we can do there as well. Yeah, so I think these are the main ones that at least I thought about. If you know any other issues with LLMs, let me know after the talk. I'm always happy to hear more problems that we can tackle. Now, in terms of solutions, let me see, by the way, is there any question? Oh, where's my slide? Oh, yeah, here. So there's no question, right? Well, I would see it here, right, if someone asks a question. Yeah, all right. So what are the solutions? So let's take a look at them. Like the first one I said, LLMs require pre- and post-processing. So for this, you probably need to use an LLM framework, right? You can, of course, do this pre- and post-processing yourself, but typically people use something like LangChain, which is a Python framework, but there's a version called LangChain for J. If you've been in talks in the morning, some people showed that in one of the talks. So you probably want to use something like LangChain to kind of help you with this pre- and post-processing. And I'll show an example later on RAG, what kind of things it gives you. But there are others, like there's Firebase Jenkins from Google. There's Semantic Kernel from Microsoft, which is C# and Python. There used to be AutoGen, but I think they kind of merged that with Semantic Kernel now, if I'm not mistaken. There are other frameworks like Llama Index, which started as a data framework, but now it's also trying to be this LLM kind of framework. And there are many others as well. These are the main ones that I looked at and use. So you typically would kind of, once you get past the initial stages of playing with LLMs, you typically would want to use one of these to make your life easier. And I have examples, a couple of examples in my repo to show how to use LangChain and how to do the same in Semantic Kernel, so on and so forth. So pick a framework and use it, typically LangChain initially. Now, in terms of hallucinations, LLMs hallucinate when they don't have the data or it's outdated. What you can do is grounding. So you try to ground the responses of the LLM. And there's a couple of ways of doing this. I call it the easy way and the hard way. So if you can do the easy way, go ahead and use it. It's very easy. But then at some point, maybe it's not going to work for you. Then you have to switch to the hard way. And the easy way depends on where you're running. But if you are running on Google Cloud, for example, there is grounding with Google Search by default. So you can just enable that. And with that, you get grounding with Google Search. And then recently, we also introduced Google Maps grounding. This is in preview, so that's for Maps data. If you want to do grounding with Maps data, you can use that as well. If you have your own private data, then you can use Vertex AI search. And the idea here is that this kind of injects your data, and then you can use Vertex AI search grounding to ground with your own private data. So these are the options that you have on Google Cloud. I mean, depending on which cloud you are running or which platform you're running, there are different ways of doing the same thing, basically. But if there's something like that, try to use it if it works for you. And I have examples of both that you can check in my repo. But Google Search Tool basically allows you to ground your model responses with Google Search results. So this gives you a couple of things. Number one, it augments your LLM with more recent data, right? Because Google Search basically has data from, like, say, yesterday or today. So you get the data, and it also kind of allows your LLM to kind of check its responses against Google Search. So with that, it tends to hallucinate less because it can use Google Search for its grounding. Similarly, well, how do you use Google Search? This is Python, but you get the idea. Like, you create a tool, Google Search tool, and then you create your client, and then you basically, in the configuration, you just point to that Google Search tool. So with basically just passing this Google Search tool, with that you can get your results. So here, for example, I'm asking, how is the weather like today in London? Normally the LLM wouldn't know this, but by grounding with Google Search, it will know, because it will ask Google Search, and then with that it will be able to answer. And same with Google Maps. This is in preview, so it's not available yet in Europe. It's only available in the US, I think. But the idea there is that instead of just Google Search, you can also use Google Maps data and do grounding that way. And actually, let's actually look at an example here. There was a research paper that models which learn on generated data deteriorate capabilities. One of the issues is the average responses. Is that a problem still? That models which learn on generated data deteriorate. I don't know if I understand the question, but maybe you can ask me after my talk. All right, what was I going to show? The grounding. So here, for example, I'm going to ask, how is the weather in Krakow today, right? And I don't have grounding enabled. So if we ask this, and by the way, 2.5 I'm using, it's a thinking model, so it will take time to think, and then you'll also see like its thinking process. So this is supposed to give you better answers. And see, like, one of the things about thinking models is that they try to answer you, even if they don't know the answer. And here it's trying to say, okay, the current temperature, and then it says insert the current temperature here. And you see, like, it's trying to give you an answer, but it's actually not the right answer, right? Like, it's like, yeah, I mean, it's trying to be useful, but it just have placeholders for the answer. So we don't actually get the answer. But then if we come here and then enable grounding, and you can see that I can choose Google Search or Google Maps, but let's go with Google Search. And then if I come back here and run it again, then it's thinking again, and then I should choose another model. If you use a flash model, it's not thinking, so it will answer more quickly. But then you'll see that it will answer and say, okay, today, May 15th, yeah, it's correct, and it's like 9 degrees. I can confirm, because it was pretty cold today. And then it also gives you the sources that it used. So it used these sources to get the weather, right? So if this works for you, and you can just enable grounding with basically creating the tool and setting it, use it, and it can make your life easier. Yeah, so that's grounding. What was the other one? Okay, and I can't show you Google Maps yet because it's not available in Europe. The other one is, LLMs might hallucinate because they are not good at calculations, but you can use something called code execution. This is another tool that you can enable. And the idea of code execution is that when you enable it, the model can generate and run Python code. And since it can generate the Python code and run it in a sandbox, it can actually give you better answers, especially if the answer requires some kind of calculation. And how do you use this? Similar to Google Search, you create a tool. This time the tool is tool code execution. And then you ask a question that requires a calculation. What is the sum of first 50 prime numbers? And then you pass in the tool. And then I am also passing temperature to 0 just to make sure that it doesn't try to be creative. Just give me the answer, you know. And then the answer should be 5117. That's the right answer, okay? So let's see actually if this works. So if I come back, and now I'm switching from Vertex AI to Google AI Studio. They're kind of the same, but this is outside the cloud. And if I ask what is the sum of the first 50 prime numbers without code execution first, let's do that. You see it's trying to do stuff and it's doing some math calculations, and then it kind of makes you believe that this is correct. But then in the end, we get 3287, which is wrong, right? It was 5117, something like that. So that's why you can never trust LLMs, even though they try to convince you that it's true. But then we know that this is a calculation kind of thing, so let's just enable this and then rerun. And then, yeah, you see that it generated the Python code, and then it will run it. And then in the end, we get the answer 5117, right? So this is the correct one. So for use cases like this, then it makes sense to enable code execution because it can help, as we see. All right. Now, code execution, Google Search, Google Maps, they work, you know, almost like magically. You just enable them, and if they work, they're great. But if you have your own private data, you can use Vertex AI Search. I didn't show you that. And that also kind of either works or not for your use case. But at some point, you probably want to build your own Retrieval-Augmented Generation pipeline, because you probably want to be able to control, you know, what things are being searched and how they're searched. So for that, you're going to use RAG, basically for more control. And the way RAG works is that, let's say you have your documents, your private documents that you want to use for grounding. You take those documents, you split them into smaller chunks so that you have small chunks of the big documents so that they don't take up too much context window in case you have a small context window. Then you vectorize them. So you change from text to vectors, what's called vectors, embeddings, which kind of preserves the meaning of the text, but in a mathematical kind of form. You say that to a vector database. And then when the user comes along and they ask a question about your data, you calculate the vector embedding again. And then at this point, you have the question in mathematical form, and you have the documents in mathematical form. You can do a similarity search against that. So given the question, what are the similar documents, basically similar chunks that I have in my vector database? You find them, first top 5 or top 10 or whatever. And then you feed that back to the LLM with the question. And also you say, please use these chunks as your context. So when LLM tries to answer, it will basically use those retrieved contexts as its grounding. And with that, you get more relevant answers and less hallucinations. That's the whole idea of RAG, okay? Of course, this is a lot of steps, so you need to think about, like, you know, how do you parse and chunk the documents, what embedding model you need to use, what vector database you should use, how do you retrieve all the documents for top 10, top 5, how do you chunk them, stuff like that. There's a lot of things you need to figure out. So that's why at this point it kind of makes sense to rely on a framework like LangChain to help with this. And let me show you an example. So let's say I have this PDF, and it's a private PDF. It's about Symbol, which is an imaginary vehicle, and it's the manual of that vehicle. So you see, it's a PDF that basically it's randomly generated that talks about this vehicle. And let's say I want the LLM to answer questions on this PDF. By default, it's not going to answer anything because it doesn't know anything about this vehicle, right? And actually, I can I can run this. For example, if I ask a question, what is the cargo capacity of Symbol, without any grounding to my LLM, it will send the prompt, and then it will give us an answer. But in the answer, it will say, you know, I don't know what you mean by Symbol. Can you give me more context? Because it doesn't know, right? Now, to actually ground it with this PDF, what we need to do is, I'll just show you the code. And this is in Python. Sorry, I know this is a Java conference. You can do all of this in LangChain4j and in Java as well, and it's quite similar. But what you need to do is basically, first, you load the PDF with PyLoader. Then you have this recursive character text splitter that splits the PDF into smaller chunks. And here I'm using the chunk size of 500 and chunk overlap of 100. So they're not too big, but they're not too small. And they also overlap a little bit so that we capture the sentences and we don't cut them off like immediately. So once I have the text documents, I create a Vertex AI embedding. This is an embedding model. And then I am using Firestore as my vector store, but there's a lot of choice here. And then from here, I pass my chunks to Firestore vector store, and this will do the embedding and then also saving to the Firestore. And then from there, I get a retriever, and this is the thing I'm going to use to retrieve the documents later. Then, so this is the ingestion part, so we are done with the ingestion. And then afterwards, I'm going to create my chat model, and then here I'm giving a system prompt. And in the system prompt, I'm basically saying that, you know, just answer the questions, but use the context, this context, and the context will come from my embeddings, from my vector database. So that's the key here. I have my prompt with the system prompt, and then here I basically combine everything together. So LangChain has this thing called create stuff documents chain. So it combines the model with the prompt, and then it combines this question answer chain with the retriever, with the vector database. So this is the part that's kind of a little bit like black box in LangChain. Like, you know, you just basically import these functions and just use them to put them together. But it kind of also helps you that you don't have to write this logic yourself. So all the RAG pipeline I show you in that diagram, all of this stuff is done basically automatically for you. So what happens is that when a user asks a question, then the LangChain will basically take that, run through the embedding model, you know, then do the search against the vector database, get the top, I think 5 or 10 by default, then feed that into the context, and then we'll get the answer and then give you the answer that way. So once you set this RAG chain, then all you need to do is instead of running against the LLM, you just run against RAG chain, and then all that stuff will be done for you. And just to show you that this works, I can come back here and let's see, Python. Yeah, so this time I'm providing a path to my PDF, and this will kick off the RAG pipeline. So all this ingestion is happening right now, and I'm using a Firestore for my thing. And then you'll see here that the system prompt includes the context from the PDF chunks that it kind of loaded. And then there's a lot of other things that's happening under the covers. But the important thing is that when you look at the response, and when we ask the question of what's the cargo capacity of symbol, now it's telling us that its cargo capacity is 13.5 cubic feet because it knows that from the PDF, right? So that's why frameworks like LangChain can be helpful in that sense. All right, that's that. LLMs rely on outdated public data. Well, you can use something called function calling. And function calling, the idea of function calling is that you basically augment your model with external APIs. So any API, like weather API or stock API or anything like that, you can kind of pass that as a tool to your LLM, and your LLM can call that and get extra data. That's the idea with function calling. And the way this works is that users comes again, they ask a question, what's the weather like in London? Then we pass that prompt to the model, but we also say to the model, you have this function called getWeather that you can use if you want. Okay, so we pass it as a tool to the LLM. Then the model looks at the question and says, okay, like the user is asking me about the weather, I have this function, can you call the function for me? So it will make a function call request to you, okay? So it won't make the call for you. It says, can you call this function for me? Then we make the call to the external API with London. We get the result back, sunny, which is never true, by the way. And then we pass that back to the LLM. And then then LLM has the information it needs, and then it will answer back with like it's sunny in London, which is again another lie. Maybe it's hallucinating, but that's the way this works. And back in the day, like when first models came along, you had to do this yourself. You had to implement this yourself. You had to kind of look for the model asking you to call a function, and you had to call it and then return back, all that kind of stuff. So you had to do a lot of things on your own. But thankfully, the libraries make this much easier now. There's automatic function calling, and I'll show you an example of this. So here's maybe I show you on GitHub instead. It's easier to see there. So this is the old version, and now I have this new version with the new SDK, so maybe I'll just show you this one. But basically, what I have here is that, this is my prompt, what's the temperature in London, Paris, and Tokyo. Then I have an API request function. Then I define two functions. One is location to latitude and longitude, because usually the weather APIs, they need a specific point for the weather. So first, given a location like London, I call a function to get the latitude and longitude. So that's function number one. And you'll realize that this function is very well documented because LLM will use this to figure out which function to call. So that's why I want to make sure that I have good description and arguments are defined and the return is defined as well. So I'm calling this geocoding API to get that. Then the second function is latitude, longitude to weather. And this is similar kind of thing. So given 2 points, it gives you the weather. And again, I'm using an open API to do this. And then all I have to do is when I'm generating my content, I pass these pure functions, like Python functions, as tools. And that's it. And then you will see that I have this commented out. So automatic function calling is enabled by default. And what this does is that basically all this dance of calling the function, returning the result to the LLM, all that kind of stuff is done automatically for you. So once you generate the model, generate the content, then you will get a response, and all this stuff, all the calls is made for you by the library, and then you get a response back. So it's very easy. But the reason why I mention this is that because it's important to know what's happening under the covers, because sometimes if your functions are complicated or if the LLM is not calling your functions, you need to debug it. So what you would do is that you would basically disable this, and then you would see the responses. At that point, you have to look at the function calling history and see what's happening under the covers. But typically, you don't need to do this anymore, which is nice. And if you come back here, and if I run this, then, well, it's not that exciting. It will just basically make all the calls, get all the results, and then in the end, yeah, you see like it says London is temperature 14.1. It's actually better than Krakow today, which is surprising. And then, yeah, Paris and Tokyo. So all this is from real APIs, real data. So we augmented our LLM with today's data. All right, I need to speed up a little bit because there's still a lot of stuff to talk about. LLM outputs can be chaotic, but thankfully this is not a problem anymore. You can define the response type with most models. You can define a schema. You can even use classes as schema nowadays with Pydantic. So the way this works is that you define a class in Python with Pydantic class, and you say, okay, I have this recipe class with name, string, description string, and ingredients, a list of strings. Then, when you generate your content, you basically say, first, this should be in JSON, the response, but then also the response should be a recipe, right? Once you do this, then you get a response back in that schema, and you can rely on it, and this works, right? So this is not a problem anymore, and you should do this if you are expecting a certain format. LLM inputs can get expensive, but you can do context caching. The idea of context caching is that, let's say you want to analyze a number of videos and ask a lot of questions about the videos. One way of doing that is that you can send the videos and then keep asking questions about it, but that will get expensive because you will be using tokens. Another way is that you can cache the videos or the PDFs or whatever, and then ask questions to that. And once you do that, it gets cheaper because you basically will be using the cached content. I won't show an example. I won't run an example, but I will show you how it looks in terms of the code. So here, context caching, basically, first what you need to do is And you can cache many things, by the way. You can cache the system instruction. You can cache, like, here I'm caching PDFs, but you can also cache like images, videos. So anything you can send to a model, you can cache them. But you would basically create a cache content with the model name, system instructions, and the contents, and also the time to live. By default, I think it's 60 minutes. And then when you generate content, you don't generate content from the model, you get the model from the cache. And then what this does is that basically makes the model aware of the cache. And then if you ask a question about the papers, for example, it will know that you're talking about the papers that you just cached, because it's, yeah, that's how it works. And then once you're done, you can delete the cache, or it will expire. So if you know that you're going to be sending a lot of data and ask a lot of questions about it, cache them, and then do it afterwards, and it will get slightly cheaper. You can also do batch generation. And the idea of batch generation is that, let's say we want to do 100 calls, 100 calls about like 100 different things that you want to analyze. You can do that one by one if you want, but then you can also batch them if you don't need the responses right away. And then what batching does is that it first parallelizes your calls, and then since you batch them, you also get a discounted price. So it gets cheaper, and it also gets parallelization. And I have an example of this. Let me show you how that looks. But it's basically typically what you would expect. So you have an input bucket for the inputs that you want to generate responses for, and the output bucket is where you're going to save the results. And then the input will be basically the request that you send to your LLM, but in JSON format. So here, I'm just saying, give me a recipe for banana bread, chocolate cake. So you see, like, it's the same kind of thing, but like 100 times, let's imagine. So that's my request that I save. And then you can also point to other things, by the way, like, again, like JPEGs or PDFs or whatever. So any request you can send, you basically take that and put it into this format. And then you create a batch job, and then you point to your files, basically your input files. The batch job will run. It will take some time. So you have to kind of do a while loop and check if it's running. And once it's done, what you will see is that you will see basically a list of results. And it will be basically like this, where you will get the status, whether it was successful or not, and then the responses you would get from the LLM. So same as calling the LLM, but in a file. And with that, you get parallelization and discounted price as well. All right. LLM calls can be slow, I said, and again, batch generation helps for that because you can parallelize them. So we covered this already, so I can skip this. And if LLM calls are slow, you probably need some kind of observability framework to look at why it's slow. There are a few different ones, but the one that I use called LangTrace, it's basically like open telemetry, but for LLM calls. And it basically tells you, you can instrument your LLM calls, and then you will get like these traces that you can look at. I won't show you an example of this. It's pretty straightforward. And it's very similar to what you're used to. But just know that there are tools for LLMs where you can get this tracing for large language model calls. All right, so the big topic is the measurement. So how do you measure LLM outputs and make sure they're good? Well, you need to use an evaluation framework. And in my repo, I looked at 3 to 4 different evaluation frameworks, and I kind of compared them. So you can check my repo for examples. But just to give you an overview, if you're on Google Cloud, there's something called Vertex AI, Gen AI evaluation service. And this has computational-based and model-based metrics that you can use. If you want to stay in open source, there's a tool called DeepEval, which is a Python-based testing framework that has a lot of metrics. There's Ragas for Retrieval-Augmented Generation metrics mainly. There's Prontful, that's also a security framework, but also metrics as well, like evaluation framework as well. There's TrueLens, and there's more. These are the ones I used and I have experience with, but there's a lot of choice here. I think the hard thing about these frameworks is that when you look at the metrics they use, like for example, DeepEval has metrics like GEval, which is based on a paper. about general evaluation of large language models. Then there are things like contextual precision, recall, relevancy, so on and so forth. Then PromptFul has similar metrics like geval and context, recall, and relevance, but they also have different things. RAGAS is more about Retrieval-Augmented Generation. So I think the challenge here is like trying to figure out which framework to use or which metric to use. You either choose the framework and then see what it supports, or maybe other way around. If you know what to measure, then you can see which framework supports it. I don't have a good answer, but when we look at the metrics, there's this good blog post from Deep Eval people. They talk about like different kind of metrics, different classes of metrics, and they basically fall into two categories. One is statistical or deterministic metrics, and the other one is model-based metrics. And the idea of statistical metrics is that these are the metrics that, given a text, it gives you a score, and it's always the same score, so they're deterministic, but they fall short in some ways that I'll talk about. And then the model-based metrics, they are basically metrics that are basically using a model under the covers. So they use a model to judge another model, right? So these are the main kind of classes of metrics. Now, if you look at the deterministic, or they're also called computational metrics, they do things like, the usual like equals, contains, and it starts with, so the usual string matching. You don't even need a framework for this. You can do this like string matching yourself if you want, but these frameworks, they support it, so you can start with that. But then there are metrics like BLUE, for example, that basically measures how closely a response matches a reference, okay? And it gives you a score on that. There's Rouge that does the same thing, but for summarization. So if you have a text to summarize, then it looks at how the summary response matches with the reference summary that you have. And there's more as well, but the problem with these metrics is that, first of all, you need a reference. So you need a reference to compare to, and if you have a reference, then great, but if you don't, then you don't get a score. And the bigger problem is that they really fall short on capturing the semantics, the language. Slight differences in the language, they basically throw off these metrics, and they don't become that useful. And actually, I'll show you an example. So here I am using Google Vertex AI Generative AI service, and let's use a computational metric. So let me show you how this looks actually. So what I do here is that let's imagine we have these responses from the large language model. So I have 3 responses. Then these are my references. So these are what I expect like as the best answer. And then I create an evaluation data set that with the responses and the reference. Then I define my metrics. So here I'm doing the exact matching, BLUE, Rouge, and there are different flavors of Rouge, but I don't care about that right now. And then I start a task and run these metrics and then get the result, right? So if we do this, let's run this and it should be quick. Then this will run against like in the cloud. Yeah, so you see we get some numbers, and so the first one, the response and the reference, they match 100%. So exact score is 1, as you expect. BLUE is 1, Rouge is 1. Okay, we expect that. The second one, I'm good or I am good, it's pretty much the same, right? The exact score is 0, so it doesn't really help us that much. BLUE is 18%. And then Rouge is 66%, right? So you see what I mean here. Like, I mean, in my mind, these are the same things, but the BLUE score doesn't capture that. If you do something like this, like the cat lay on the mat or the cat sat on the mat, it's almost the same kind of thing. BLUE says 48%, Rouge says 83%, maybe slightly better. So that's why these metrics are okay to start, but they don't really help too much. And that's why people are switching to model-based metrics. And in model-based metrics, there's a lot of different metrics that you can check. But the idea is that you use one model as a judge to evaluate another model. The bigger question here is that, can you rely on LLM to grade another LLM? And according to the paper that GeeCON is based on, the answer is yes. Like LLMs actually are really almost as good as and better than in some cases than human evaluators. So it tends to work if you structure your prompts properly. I have examples of this in PROMPTFul and DeepEval, but I have 5 minutes left. I don't know what happened to time. So let me just show you one example of how this works. For example, here I am in DeepEval, and I want to, DeepEval has a lot of different metrics, but let's pick one, which is answer relevancy. Answer relevancy answers the question of, given this question, is the answer relevant to the question? So what you do in this case is that first you have a test model. This is a model that you want to test, and this is an evaluation model that you want to use to evaluate this test model. Typically, your evaluation model, you want something more powerful. So here I'm using Pro. And then I create my LLM client. This is my input, why is sky blue? Then I get my response from the LLM. And now I want to evaluate. So I create a test case with the input and the output. Then I create my evaluation model with my more powerful model. And the metric I choose is the answer relevance metric. And I pass in my evaluation model. I set a threshold. So if it's 80%, then I will accept that as pass. And then I just assert the test. So you see, it's kind of like a unit testing, but for metrics. And if we run this, DeepEval, if we run this, it will do the evaluation, and then it should give us a score, and it will tell us why it gave that score with a reason, basically. So let's see if that works. I don't know what happened to time. It really flew. I still have a lot of stuff to talk about, but maybe I'll just do a really quick overview of what I wanted to say, and then if you have more questions, you can find me after the talk. So you see, we ran it, and then the score we got is 78%, which is failed because threshold was 80%, and it tells us why. The score is 78% because it tries to address the sky is blue, but it contains several irrelevant statements about the color of the sky at sunrise. Okay, so we have to take a look at that. So you can do that. There's PROMPTFul, also has similar kind of thing, but it's YAML based, so you can take a look at that. I have examples. I'm almost out of time, but so what I'm going to do, I'm going to tell you the rest of the stuff really quickly. So for RAG, if you're doing Retrieval-Augmented Generation, there are metrics for that too. So RAG has two parts, the retriever part and the generator part. So for each of them, there's different metrics. So for retriever, there's contextual relevance, context recall, and context precision that you can measure. And for generator metrics, there's answer relevance and faithfulness that you can measure. So these are the main things you can measure. But people typically don't measure these two because they require reference. And they only measure this one, and that one. And that's why you see something called RAG triad that basically looks at your RAG system as a whole and just measures these three different metrics. And DeepEval has these metrics, and you can actually write a RAG triad metric pretty easily. And I showed it as an example in my repo. And then more recently, there are metrics around tools. So you saw that the LLM called the function, weather function. So there are things you can measure there. Or if you have agents, then you can also see how the agent is using your tools and whether it's calling the tools in the right order. So for tool metrics, you can measure things like, is the tool called valid? Is it supposed to call this tool? Does the tool name match? Key value, does the key match or the key value match? And then in terms of agent metrics, you typically look at how the agent is calling the tools. So what's called the trajectory. So that is it matching the trajectory that you expect, basically. And I show an example of this with Vertex AI and how you can measure these things. And then for the outputs, like harmful content or PAI, you need to use a security framework. And then the main security frameworks, PROMPTFul is one I mentioned. There's something called LLM Guard that basically sits between your application and LLM and applies some controls in the input and the output. And then there's something called Guardrails AI that I use as well. And there's more, but these are the main ones that I know. And yeah, the idea is basically like have something in the middle to check for things. And just to show you just the LLM Guard, the way that works is that, let's see. So basically, you can apply input and output controls. Like here, for example, I create an input scanner, and I want to ban all the code as input. And then I scan through that before sending to the LLM. And then you can do similar things. Like, for example, here, I want to ban all the languages, basically, except French, right? So I create a language scanner, And then if it's not French, then I can block that on the way out. And then they also have anonymized and de-anonymized scanners. So let's say you have this prompt with personal information. You can pass that through an anonymized scanner, and it returns that into this sanitized prompt. And then you get this sanitized prompt, you send it to the LLM, and then once you get back the result from the LLM, you can de-anonymize it and get back to the user information. So that way you're dealing with real user information, but you're not sending to the LLM. And then once you get the result back, you can apply what you need to apply. And you can chain these all together and stuff like that. But sorry, I'm out of time. So hopefully this was useful to you. And this is kind of the summary of what I said today. I don't know, do I have time to answer questions? Yes? Okay. So let me check what questions we have. This one. Okay. What is the temperature for calls? Can you provide some examples of how to temperature parameterize? Well, temperature is kind of like how creative you want the LLM to get. So if temperature is 0, then it tries to choose the most probable answer. But then if your temperature is higher, then it will choose different answers. It won't choose the most probable answer, but it will choose other answers once in a while. So that way, I mean, you can think of it as kind of like the creativity parameter. So the more it is, then the more random the responses will get. You said to use code for calculations, but if the model can hallucinate without code, how can you be sure that it will create accurate code? You can never be sure with LLMs. You know, like it can always give you wrong answer or generate code that doesn't work or generate code that's not correct. But as you've seen, it can help. So it can make calculation-based responses better, but you can never trust it, of course. What are the best free, locally runnable language models for laptops suitable for offline use and experimentation? From Google, Gemma. Gemma is the best open model, and there are other models, of course, open models, but I haven't personally used them, so I can't really comment for the rest. But Gemma, I know that it's the model that that we have that seems to be pretty good. Caching memory. Yeah, maybe. I don't know what the question is. It's caching so that you can reuse the context, basically, so that you don't have to pay for it. Because every time you send the context, like video, you have to pay for it. But when you cache it, you don't have to pay for it. Well, you have to pay for the first time, but the rest of them are going to be much, not free, but much cheaper, basically. Can you please provide a link to the presentation? Yeah, so speaker deck, I have it. Where is it? Yeah, if you go here, then I have all my presentations, including this one. So yeah, feel free to get it. Or find me on LinkedIn, I'll also send you the link there. And then last one, how will you scale evaluation? Doing prompt check one by one, is it hard to do good overall level? Let's say you want to test at least 10,000 examples. Yeah, so in Vertex AI Gen AI evaluation service, you've seen I had the responses in a list. But what you would typically do is that you would basically, you would have the reference in a file, and then maybe you also have the responses from the LLM in a file, and then you would kind of run those, load them from a file and then run them that way. So there's one way of doing that. I mean, you still need to kind of, if you want 10,000 examples, you need to run that 10,000 times against the LLM, I guess. So I don't know if you want to do that many. So you have to find the right balance, basically, how many, you at least need 100 examples or so, but I don't think you would need 10,000. You will probably need 100, 200 would give you a good, score to rely on. And then, yeah, you just basically, maybe you have the references in a file, and then you run a batch generation of the 100 requests to the LLM, and then save that to a file, and then you load that up into your evaluation framework, and then run it that way. So that's what I would do. But let me know if you have a better idea. All right, thanks very much.